Hi everyone, welcome back. In this section 8.3 we're going to talk about perimeter and area. So perimeter is just the sum of the lengths of the sides of a two-dimensional figure, and we designate perimeter with a capital P. And in the example that I provided with the rectangle, we've got it made up of squares, so we can kind of visualize perimeter and area. So the dimensions of the rectangle are 3 units and the other is 5 units. So it's a 3 by 5. And if I want to find the perimeter, I'm just going to add up the lengths of the sides. So if you'll recall from 8.2, one of the properties of rectangles is that the opposite sides are congruent. So if this side here is 3 units long, then this side across from it that's opposite it is also 3. And then I've got 5 units along the base, so opposite that would also be 5. So in order to find the perimeter, I'm just going to add up 5 plus 5 plus 3 plus 3, and they end up with 16 units. There is a formula that you can use to find the perimeter of a rectangle also, and that's 2 times the length plus 2 times the width. So the length and width could be either the 5 or the 3, it doesn't matter. So if we make the length 5 and the width 3, I'm just going to substitute in. And doing order of operations, I'm going to multiply first before I add. So 2 times 5 gives me 10, plus 2 times 3 is 6, and I end up with 16 units. And it's always measured in the same units as the sides are. So if the sides were in inches, the perimeter would be in inches. The area is what's on the inside of the figure, and formally the definition is just the measure of the region within the boundaries of the figure. So you want to remember that perimeter, like think of perimeter alarm, it guards the outside of the figure. Perimeter deals with the outside, and area is the inside. So if I want to find the area, I am looking at what is on the inside of that figure. So in this case, you could count. You've got three squares, plus another 3 is 6, plus another 3 is 9, 12, 15. Or you could just multiply length times width. So 3 times 5 is 15, and we label area in square units. So it's 15 units squared. I've listed some formulas that you'll need to find the area of some common polygons. So the formula for area of a rectangle, you can use length times width. For area of a square, one of the properties of a square is that all the sides are the same. So you can just do side times side or side squared. So remember, s times s is really just s squared. So it ends up being side squared. So if I knew that all the sides were, say, 4, to find the area, you would just do 4 squared, which equals 16 units squared. A parallelogram is another 4-sided figure, and if we want to find the area, we multiply the base times the height. So the base and the height will always form a right angle. This is also known as perpendicular, so you may have heard of that word before. Perpendicular lines are 2 lines that intersect to form a 90-degree angle. So if I look at the height, which is right here, and I look at the base, which goes along the bottom there, you've got a 90-degree angle. That's how I can tell what the base and the height are. So I would just take those 2 numbers and multiply them. A triangle also has a base and a height. So if I want to find the area, I would just take 1/2 times the base times the height. And then another 4-sided figure, the trapezoid, is area equals 1/2 times the height times base 1 plus base 2. So the bases are going to be the 2 sides that are parallel to each other. So recall that parallel are two lines that intersect, that two lines that are in the same plane that never intersect, right? So they're coplanar, they're in the same plane, they will never intersect. And if you look at side DC and you look at side AB, they're in the same plane, a flat surface, but they will never intersect each other. And then the height, of course, is always perpendicular or forms a 90-degree angle with the base. Okay, let's look at some examples, especially where we can apply area and perimeter, because it's something that you can use in life, right? Geometry is very real life. There's a lot of concepts that we use in the real world that you can apply. So feel free to pause the video and read the problem a couple times to understand what's going on, and then we'll work it out together. It says Malik wishes to install mahogany hardwood flooring in his home office. The rectangular office floor measures 18.5 feet by 12.5 feet. The flooring is sold in cartons that cost $220, and each carton contains 20 square feet of flooring. Only whole cartons of flooring may be purchased. First question says, determine the area of the office floor. So I need to know what shape the office is, and it's a rectangle. So to find the area of a rectangle, we're just going to multiply the length times the width. So in this case, it tells us it's 18.5 feet by 12.5 feet. So all we're going to do is simply multiply 18.5 times 12.5. It doesn't matter which of those dimensions is the length and which one is the width. When you multiply those together, you end up with 231.25, and we're dealing with feet, so area is always squared units, so it's 231.25 feet squared. In number 2, it asks us to determine the number of cartons of flooring Malik will need to purchase. So we know, if we go back to the problem, that each carton contains 20 square feet of flooring, right? So that's another way of writing that is 20 feet squared. So to figure out how many cartons of flooring I would need, I need to take the area, which is 231.25 feet squared, and divide that by 20 feet squared, because every carton contains 20 square feet of flooring. And when you divide them, you get 11.5625. So now, in real life, you can't just purchase 11 cartons and then 0.5625 of another. So you would have to buy 12 cartons. So you'll have some left over, which is good in case you make any mistakes. And then the last thing it asks us to do is determine the cost of the flooring purchased. Okay, so pretend you're going to Home Depot or Lowe's and you buy 12 cartons of hardwood. Every carton is $220. So if I want to figure out how much money I spent, I would take the number of cartons, which is 12, and multiply it by the cost. And it's $220 per carton. When you do that, you end up with $2,640. The next concept we're going to talk about is an important one. It's called the Pythagorean theorem. It's named after a Greek mathematician, Pythagoras. And in the Pythagorean theorem, it is used for right triangles only. So if it's a, not a right triangle, you can't use the Pythagorean theorem. We have other methods in math that we use to determine missing sides. So the way the Pythagorean theorem works is you have to have a right triangle, and in a right triangle, you have what's called the legs and the hypotenuse. The hypotenuse is always across from the 90-degree angle. So remember that a 90-degree angle will have a square, and then just go right across from it. That will take you to the hypotenuse. And in the Pythagorean theorem, the hypotenuse is the letter C. The other two sides are called legs. And it doesn't matter which leg is which. So Pythagoras found that if you take one leg and you square it, so remember, when you square something, it means you just multiply it by itself. So leg squared is just leg times leg. So 3 squared would be 3 times 3. So he found if you take the square of one leg plus the square of the other leg, it's going to equal the hypotenuse squared. So a triangle that appears a lot, a right triangle, is the 3, 4, 5 triangle. So the hypotenuse is always going to be the longest side. So if the hypotenuse was 5 and my legs were 3 and 4, Pythagoras looked at this triangle and he saw a pattern where he said, okay, if I take 3 squared and I add 4 squared, it's going to equal 5 squared. 3 squared is 3 times 3, which is 9, and 4 squared is 4 times 4, which is 16, and 5 squared is 5 times 5, which is 25. And if you add 9 plus 16, you get 25. So the left and the right side are equal. So his formula works. And the formula is right here. It's a squared plus b squared equals c squared. And the important thing to remember is that the c always is the hypotenuse. Okay, let's look at an application. So it says the moat surrounding a castle is 18 feet wide, and the wall by the moat of the castle is 24 feet high, as you can see in the diagram. If an invading army wishes to use a ladder to cross the moat and reach the top of the wall, how long must the ladder be? So I'm looking for the length of this ladder, which we'll call x. Here's your right triangle. That's your right angle right there. I know that's making a 90-degree angle. The actual wall and the castle and the ground. So if I want to find the length of the ladder, what is the minimum length it should be to reach the top? I can use a right triangle because I can use the Pythagorean theorem. I have a right triangle and I'm missing only one side. So the Pythagorean theorem is a squared plus b squared equals c squared. And the important thing here is that this has to be c because it's the hypotenuse. And again, how do I know it's the hypotenuse? It's across from the 90-degree angle. So 24 and 18 are your legs. And it doesn't matter which one is which. So I'm just going to make 18 my A, and you're going to square it. And 24 is my B, and I'm going to square it. And we're looking for X, and we're going to square that too. So now when you multiply, 18 squared is 18 times 18, which is 324. And 24 squared is 576. And when you add those together, you get 900. So now I need x, but I have x squared. So to undo a square, we're going to take the square root. Most calculators have a square root button. Depending on what calculator you use, you may have to hit the 900 and then the square root button. Other calculators, you would hit square root and then 900. So it just depends on what kind of calculator you have. But when you take the square root of 900, you end up with 30. So that's how tall the ladder would need to be, at least 30 feet high, in order to reach the top of the castle. You should pause the video right now and then try these two problems on your own, and then you can unpause and see if you did them correctly. So for this problem, they want us to find the length of the unknown side, find the perimeter, and then find the area. So the side I'm looking for is C. There's two things I need to check. It needs to be a right triangle, which it is because it's got the box right there. And then it also needs to have only one side missing, which it does. C is the missing side. So that means I can use the Pythagorean theorem. So for letter A, I'm going to do a squared plus b squared equals c squared. And here, the hypotenuse, which is across from the 90, happens to be C. And 10 and 24 are your A and your B. And again, it doesn't matter which is which. So now when you simplify, you're going to take 10 squared, that's 10 times 10, which is 100, and 24 squared is 576. I'm going to add the 100 and the 576, so I get 676 equals C squared. And then remember, you have A squared. How do I undo A square? Take the square root. And the square root of C squared is just C. The square root of 676 is 26. So C is 26. So that's the length of that side. Now for part B, they're asking for the perimeter. So recall the perimeter is just the sum of the lengths of the outside. So to get the perimeter, capital P, I'm just going to add 10 plus 24 plus 26. So my perimeter is 60 centimeters. And in letter C, it asks for the area. So the area of a triangle is 1/2 the base times the height. Now, what would my base and my height be? Remember that I said the base and height have to form a right angle. So if you look at this triangle, this leg and this leg, the A and the B, are going to be your base and your height because they make a 90-degree angle. So it doesn't matter which one's your base and which one's your height, you're just going to plug them in. So I've got 1/2 times 10 times 24. If you're typing this into your calculator, you can use 0.5 for a half. So 0.5 times 10 times 24 gives us 120. Remember, when you label area, it's squared units. So here, it's centimeters squared. And in number 2, they're asking us to find the length of the unknown side in the triangle. This time, we're looking for a leg. 13 is your hypotenuse because it's across from the 90. And 5 is your other leg. So be careful when you plug this into the formula. So I have A squared plus B squared equals C squared. So A is going to be 5, B is my unknown, and C is going to be 13. Again, it's the hypotenuse, it's across from the 90-degree angle. So 5 squared gives me 25 plus B squared equals 13 squared, which is 169. Now I need to get the B by itself, so I have to move the 25. And remember, we do inverse operation, so you're going to subtract. So we get B squared equals 169 minus 25 is 144. Okay, I'm going to continue my work right here. So we have B squared equals 144. How do I undo the square? You take the square root. And when you take the square root of 144, you end up with 12. So 12 would be B. Now we're going to look at circumference and area, which deal with circles. Think of circumference as the perimeter. A circle doesn't have any sides, so we can't say it's the length of all the sides added up. Circumference is just the distance around the circle. And when we find the circumference, there's 2 formulas you can use. You can either multiply the diameter times pi, or you can do 2 times pi times the radius. Okay, so what's the diameter and what's the radius? Every circle has a center, and it's the middle of the circle. If a segment passes through the center from one side to the other, it's called the diameter. If you have half of the diameter, then that's the radius. So the radius will start at the center and go to one side of the circle. So what's pi? Pi is the ratio of a circle's circumference to its diameter. So an interesting fact about circles, if you take anything that's circular and you measure the circumference, and then you measure the diameter of that circle. So take a tape measure and just measure straight across through the center, like how long it is. If you divide a circle's circumference by its diameter, it's always going to equal the same number. And the number it equals is 3.14. So pi is approximately equal to 3.14. We say approximately because it's irrational, which means it goes on forever and it never ends. So it's like 3.14159, blah, blah, blah. It's a lot of numbers. So mathematicians just said, 3.14 is good enough. If you want a more accurate answer, most calculators, especially scientific calculators, have a pi key that you can use on your calculator. So if you use that instead of 3.14, your answer may be different because of a rounding error. So in other words, the more accurate you use a number for pi, the more off your answer might be compared to someone who just uses 3.14. So the choice is yours, but the directions will usually tell you whether to use the pi key, or if it doesn't, then you can just use 3.14. I usually will use the pi key just to be more accurate. And if I want to find the area, I'm going to use pi r squared. So that's pi times radius times radius. Okay, let's look at a problem. So you can pause the video and read the example. It's a long one. There's a lot of information. Read it a few times if you have to, and then unpause it when you're ready to watch how to solve it. It says Jana wishes to order a large cheese pizza. She can choose among 3 pizza parlors in town: Anthony's, Blaze, and Papa John's. Anthony's large pizza is a round 16-inch diameter pizza that sells for $15. Blaze's large pizza is a round 14-inch diameter pizza that sells for $12. And Papa John's large cheese pizza is a square 12-inch by 12-inch pizza that sells for $10. All 3 pizzas have the same thickness. To get the most for her money, from which pizza parlor should Jana order her pizza? Okay, so let's break this down. We've got our 3 pizza parlors. We've got Anthony's, and we have Blaze, and Papa John's. Okay, let's draw a picture. So according to what we just read, who has the largest pizza? Well, when we're dealing with the circles, it would be Anthony's because they have a 16-inch diameter pizza compared to Blaze, which has a 14-inch diameter. So we're going to make the Blaze pizza just a little bit smaller. Okay, so there's the center. This looks like it's about the center. And then for Papa John's, it's more like this. Okay, so let's label. It says that Anthony's large pizza has a diameter of 16. So remember, diameter is just a segment that has 2 endpoints on the circle and it passes through the center. So it's saying that this whole length there is 16 inches. And then Blaze has a, see if I can move that. Nope. Yes, I can. Okay, make it a little more accurate. So Blaze has a 12-inch diameter pizza. So it's saying that this is 12 inches. I'm sorry, 14 it should be. Whoops, I did not want to get rid of that, but it looks like I'm going to have to. Okay, so let's do this. Okay, here we go again. Okay, and this is 14 inches. And then we have our cheese pizza from Papa John's. It says it's square and it's 12 inches by 12 inches. Okay, so the first thing I need to do is I need to find the area in order to figure out which one I'm getting the most, Jane is getting the most for her money. So to find the area, the formula is pi times radius squared. So pi is just 3.14. If the diameter is 16, to get the radius, I'm just going to divide it by 2. Remember, the radius is just half the diameter. So half of 16 would be 8. And half of 14 is 7. So I'm going to plug in 8 for here. And I'm just going to multiply 8 squared. 8 times 8 is 64. And I'm just going to put the pi symbol right there. We know pi is 3.14, so no need to multiply. And then to get the area of blazes, I'm going to do the same thing, except I'm going to multiply pi times 7 squared. 7 squared is 49, and then pi. So right now, this represents my area. The area of Anthony's Pizza is 64 pi inches squared. The area of Blazes is 49 pi inches squared. And now I have a square. How do I find the area of a square? Remember, it's side squared. So for this one, I'm going to do 12 squared, which is 144. So the area of Papa John's Pizza is 144 inches squared. Now, that's the area of the pizza. The question is, to get the most for her money, from which pizza parlor should Jana order her pizza? So now what I need to do is figure out, the cost per square inch. Okay, so that's really what it's asking me for, right? I need the cost per square inch. So I'm going to take the cost of each and divide by square inches as area. So it's really asking me, take cost and divide it by the area. So what I'm going to do is I'm going to take the cost and divide by the area. So Anthony's Pizza is $15, and I'm going to divide by the area. And this is going to give me the cost per square inch. So when you do this, you're going to get around a number that's 0.0746. So that's like 7.5 cents if we're looking at dollars and cents. For Blaze, their pizza is $12. So I'm going to take $12 and divide by 49 pi. So when you do that, you get something like 0.0780. So this is like 7.8 cents. And then for Papa John's, theirs is $10, and I'm going to divide 10 by 144, and I get 0.0684. Sorry, 94. So that's going to be about $6, 6.9 cents. So overall, which pizza parlor should Jana order her pizza? To get the most for her money, she's going to want to order from Papa John's because it's the cheapest per square inch. It's 6.9 cents per square inch compared to Anthony's and Blaze, which are 7.5 cents and 7.8 cents per square inch. So you're paying more money per square inch. And for Papa John's, you're paying less money per square inch. Okay, pause the video and try determining the area of the shaded figure, and then unpause it when you're ready. So for this problem, if you haven't figured it out yet, we're dealing with a trapezoid. It has 4 sides, and I see 2 sides that are parallel. So this side is parallel to this one. So it's got 2 bases. So right away, I know this is my base, and this is my base. And it doesn't matter which is base 1 and which is base 2. So what I need to do is find the area of just the shaded part. So think of this as like cookie cutters, right? If you ever made cookies, pretend you roll out the dough and then you cut out the cookies. So the cookie would be the circle. What we need to do is take the cookie out of the dough. So you're subtracting the circle out. So I need to first find the area of the trapezoid. And if you remember, the area of a trapezoid is half the height times base 1 plus base 2. Okay, so now you might look at this and go, okay, wait a minute, what's the height? It's not there. It is, they're just not giving it to you. So 4 inches right here, which is the radius, it's the same distance from here to here as it is from here to here. That's also 4 inches. All radii are always equal. So you could go all the way around that circle as long as you're going from the center to an edge of the circle, it's going to be 4 inches. So now if I go all the way through, that diameter now becomes my height. That's the height of the trapezoid. So the height is going to be 8. And the bases are 20 plus 9. So I'm going to take half of 8, which is 4, and multiply by 29. And when you do that, the area of the trapezoid comes out to be 116 inches squared. Now I need to subtract out the area of the circle. So I need to find the area of the circle. And remember, the area of a circle is pi times radius squared. So all I need to do here is take pi times my radius and square it. My radius is 4 squared. So this comes out to be 4 times 4, which is 16 pi inches squared. So now to find the area of the shaded, I need to take the area of the trapezoid and subtract the area of the circle. And if you type that into your calculator, 116 minus 16 times pi, you'll end up with 65.73 inches squared, which is the area of just the shaded part. Now, one of the final things that we're going to talk about is square unit conversion. Sometimes we need to convert different labels, feet to inches, inches to feet, and so on. So in this problem, we're asked to convert 1 square foot to square inches. So what you need to remember is that there are 12 inches in 1 foot. So if I want 1 square foot, all I have to do is square both sides. So 1 square foot is equal to 12 squared inches. So 12 squared, 12 times 12 is 144. So 1 square foot equals 144 inches squared, which is important because that's going to help us convert other problems. So in number 2 now, we're converting 432 inches squared to square feet. So I need to take 432 inches squared, and I'm going to take my conversion that I just figured out, which is 1 foot squared equals 144 inches squared. So I basically need to change it to square feet. So I need the inches squared to cancel out. So I'm going to put 144 inches squared in the denominator, and I'm going to put 1 foot squared in the numerator. 1 foot squared over 144 inches squared just equals 1 because they're congruent to each other. So now the inches squared, they're going to cancel. And all you would be left with is 432 times 1 over 144. And if you divide them, 432 divided by 144, you end up with 3 feet squared. So 432 inches squared is actually just 3 square feet. Okay, pause the video and try the problem below, and then feel free to unpause when you're ready to figure out how to solve it. So now we're converting 37 feet squared to square inches. So now we're going from feet squared to square inches. So I'm going to do the same thing, take 37 feet squared, but now I need the feet squared to cancel. So I'm going to take my fraction and just flip it. So I'm going to put 1 foot squared on the bottom and 144 inches squared on the top. So now the feet squared are going to cancel, and instead of dividing, you're going to multiply 3 times 144. And when you do that, you get oh, sorry, it's 37, right? So 37 times 144. So you get 5,328 inches squared. Okay, last example. Feel free to pause and read it and then try it on your own. Gabriella wishes to purchase and have marble flooring installed in the boardroom at her company headquarters. The rectangular boardroom measures 33 feet by 15 feet. The cost of the flooring, including installation, is $245 per square yard. Determine the area of the boardroom floor in square yards. So the first thing I need to do is find the area, and we know that it's a rectangle. How do I find the area of a rectangle? Length times width. So I'm just going to multiply 33 times 15. And the area comes out to be 495 feet squared. The answer needs to be in terms of square yards, so I have to convert. So the conversions we did earlier are going to help us figure this out. So what I need to do now, though, is figure out what the relationship is between feet and yards. So do you know how many feet are in 1 yard? There's 3 feet in 1 yard. I need square yards, so we're going to do just like we did in the example above. I'm going to square the yards. So I also have to square the feet. 3 squared is 9. So 9 square feet is equal to 1 square yard. We're going to use this conversion now to write our answer in square yards. So just like I did above, I need the feet squared to cancel. So I'm going to put 9 feet squared in the denominator and 1 square yard in the top. The feet squared are going to cancel. So I'll have 495 times 1, which is 495, divided by 9. And when you do that, you get 55 yards squared. Letter B says determine the cost of the marble flooring for the boardroom. So we know that it's $245 per square yard. How many square yards do I have? 55. So you're going to take 55 square yards and multiply it by 245 per square yard. So the square yards are going to cancel and you're left with just dollars because you're looking for cost. So 55 times 245 is $13,475. All right, everyone, I hope you enjoyed the video. And if you need any help, please don't hesitate to reach out to me. Make sure you're working on my lab assignments, 8.1, 8.2, and 8.3. Have a great rest of your day.